Folks, it's really cozy in here. So what I propose, let's maybe just ask you questions during the talk.
Sure.
Let's make it more immersive, maybe.
Sure. Sounds good.
Can you hear me well, or do you want to move closer?
Okay.
Yeah, okay.
Good.
This is how I look when it's not like real me, but a nice Photoshop and a human who can take a photo of me. Maria already told a lot of things about me. I continue lying in my presentation. I say that I'm saying that I have 10 years of experience in JVM. It's blatant lie. I mean, it's at least 15 already. I just do not care to update the slide ever. And obviously, I use Spring a lot. Do you use Spring? Okay. Yeah. My Twitter and Blue Sky handles are at the bottom of the screen during almost the whole presentation, so you can follow me. I should probably say a couple of words about Bellsoft. We are a JDK vendor. Who heard about Bellsoft? Who heard about Liberica JDK? No one. Okay. Which Java distributions do you use? Is it like Amazon Corretto, Tamarin, OpenJDK?
Tamarin.
Tamarin?
Yeah,
Why?
yes. Oh, I guess more like the standard. Well, not standard, but open, right? And open source and the original.
This will be a minute of advertisement of myself. When you go to the Bellsoft site, it's bellsw.com. There is this chat window, and you can ask a technical question about Spring about Java or any other technologies we have. And I'm the person who actually answers these technical questions. If you will ask anything about prices, I cannot answer. It will be our sales team, and I do not really care. We are probably the only JDK vendor who has such a feature that, like, a living human who can look at your crash dump and say, okay, I know it's not our fault. It's somewhere in your software. Yeah, we contribute a lot to JDK. For example, we are a contributor and actually author of ARM32 support for JDK. It was the thing from which Bellsoft started, actually. Like, Oracle didn't want to support ARM32, so initiative group inside Oracle told, okay, we are ready to do it. And they created a company, Bellsoft, around one single supported CPU architecture, ARM32. Now it's not that popular. Still, if you use Raspberry Pi, we are probably your best shot because we still support ARM32. Oracle already deprecated it. We still didn't. We have our own base images. We have a lot of them. Like, if you want to use Java, for like the smallest image we have is GRE. It's around 28 megabytes. I betcha it's smaller than anything you can find, well, at least in open source, in an open source competition. Probably someone has smaller JDKs, but they won't have it on Docker Hub. We have it on Docker Hub. You can download it from our site, and probably even install from SDK-man. If you use SDK-man, well, like, we are in all the possible distributions channels, obviously. We also have our own Linux alpaca. So if you want to run, I don't know, your stack fully supported by one vendor, and it's not Red Hat, then it's us. We have our Linux and we have our Java. You can run the whole application in the supported stack. Also, we are officially recommended by Spring. Like, if you open this page called spring.io, there will be, we recommend use Liberica JDK with Spring Framework or something like that. And yeah, no. They test Spring with us. We provide them custom patches if it's needed, and so on. We know our stuff. So let's jump quickly to our main topic. The topic is kind of clickbaity, right? Crafting ultimate image. What's ultimate? Honestly, I do not have an answer, because answer depends on your business case and on your business's needs, obviously. What I think it can be, like, either smallest possible image, because you wanna something like fast deploys, for example, or you want to have an image which starts up faster. For some businesses, it's very important. We don't want to wait. I know this huge enterprises Spring application which can start up for like 5 to 20 minutes. I actually do not like to be the developer who develops these applications. And for me, in this case, making it start up faster is kind of priority. Or it can also be something in between. Probably you want some trade-off between ultimate fast startup time and ultimate size, because, well, this is how it works. The whole development is about trade-off management, right? You always make decisions what trade-off I'm ready to accept because it works for my business better this way. Let's discuss all of them. But first, I want to tell you a song about the worst possible Docker image you can build with your application. Who is familiar with Dockerfile syntax? Okay. So, but let me explain quickly. The first line here is it's our base image, and here I say I want to use JDK 21. 21 is just the latest LTS release we have. JDK is obviously huge. It includes everything you can possibly need from Java, like compilation, I don't know, whatever, JLink, and so on. Then I copy my application inside Docker image. And then I build my application right inside Docker image. And then I say, when I run this Docker image, please just run java-jar. And it's actually a working scenario. Like, you actually can do it this way. There are some issues, though. Like, each directive in Dockerfile is written, result of its execution is written on top of what was written in the layers down. So layers are immutable. Some layers are zero size, though. Like, for example, entry point is just a metadata in our image. It essentially weighs nothing. As a small example, if we create a very simple image from Bash, then we copy our application, and then we delete our application. In a perfect world, it would be very cool if Docker image would be like of almost zero size, because there is no our application anymore. But it's not the reality in which we live. In our reality, we will still have the size of our application plus Bash. So if we look at our Dockerfile again, here we actually do a lot of work, and here we do not do any work. And if we look at the resulting image, it will be something like this. First we have 7.5 megabytes, just some base of our image. Then we have, excuse me, please. Then we have a lot of metadata, environments, labels, and so on. Then we have 100 megabytes of our JDK. It's relatively small, but still hefty. But we won't talk about it today. Then we have 67 megabytes of our application in our Docker. Why is it 67 megabytes? Because obviously it's not source code, right? It's 67 megabytes because no one writes Docker ignore files. Well, I hope that you do, but in a bad scenario, worst case scenario, people don't even know that what Docker ignore is. And it means that all the built binaries we have in our application, all the libraries, all the dependencies are copied at this place. And here we have 512 megabytes, which is actually a very beautiful round number. We just don't want to have it in our image. It's all the work Gradle did to build our application. And then we have our latest layer of zero size, where we just launch our application. So it's 580 megabytes, which are changed on every build, because our application is slightly changed, what the Gradle did is slightly changed. Why do we care at all? Like, why is it important at all? Because in the perfect world again, it's all working on our machines. But in the real world, we have to push it into production somehow. For that, we have container registry like Nexus or Artifactory probably, or maybe Docker Hub, depending on your business. And you really don't want to push 580 megabytes every time for small project. For a bigger project, it will be more, obviously, because more dependencies and so on. And what's even worse, you don't want to pull 580 megabytes on every server you run your application. Like if we imagine a hypothetical situation when you run your application on Google Cloud on 1,000 nodes, it will mean you pull gigabytes of data, almost more than half a terabyte of data for this particular application just to roll it out. It's probably not what you want. It takes a lot of time, and everyone prefers their rollouts to be faster, or at least controllable. So let's start optimizing it. The simplest thing we can do is to actually build our application outside of container, then just copy. Sorry, it's what we had. What was it? Sorry. This is what we had. This is how we change it. We build the application on our machine, then we just copy it to the Dockerfile, to Docker image, and then we run it. And it's actually very good. It has actually very good outcomes. This is what we had. Again, 67 megabytes of our application and 512 megabytes of dependencies and so on, which are replaced by just 60 megabytes of our compiled application. And this is kind of one line that saved us more than 500 megabytes, which is amazing, which is actually very good. But there is an issue. Build is not clean now, right? Because when we build something on our machine, build can be dependent on our environment. It can unpredictably affect our environment. It actually happened to me once. I had an environment variable for something which changed the behavior of compiler and behavior of application. And I built it and I rolled it out to production and it works perfectly. But then someone else built it on their machine, and they didn't have this environment variable, and everything went sideways because, well, production failed like five minutes down the line, and no one understood why. Yeah. Yes, we can. We shouldn't. We can. Yeah. So. This can be solved with build stages, with the Docker build stages. Who knows Docker build stages? Okay, no one. Nice. Hopefully you will learn something new today. Multi-stage builds allow us to solve some problems. They allow us to create clean builds, environment independent. They allow us for more optimal packaging. We will talk about it, obviously. And what's even more interesting, you can use different base images. For example, you can use JDK to build your application, but then in production, you will run your application on GRE, not on JDK, which is significantly smaller, like probably 10 times smaller, depending on your packaging and so on. The very simple example of staged build looks like this. So I have this first layer called builder, and I have this library runtime container, JDK muscle, where I copy my application, full application, do not care about Docker ignore, do not care about anything. And then I call grelw build -x test, just because I want my build pass faster. It is exactly the same thing we had in our first example. But there it was bad because we had like 500 megabytes overhead. Here we create a second stage, which we call runner. And if you look at this line, highlighted line carefully, it's GRE, not JDK, exactly what I was talking about. And the thing we do next is we copy data. We copy the build jar file from the stage called builder, named builder, to our current stage, to /app/app.jar. I omitted entry point for unknown reason here. entry point is somewhere here, and it says entry point java-jar app.jar. And if we look at the structure of the file of the resulting container, it's something like this. We can see that again, there is only one additional layer. It's our application, 60 megabytes. And this time, the build is clean. It is environment independent. That's all. Yeah, we can probably, yeah.
Just a real question.
Yeah.
So you use the JRE in the run.
Yes.
But don't you run into the problem with the tools jar for a server application?
Question is for the recording. If I run my production GRE, don't I need a tools jar for my server application? Answer is usually no. If you do not do any compilation stuff, sometimes you need it, but I would call them rare scenarios. In usual productions, GRE is more than enough. You have all the modules you need, you have the stdlib, you have JMX. You actually can cut it even further if you use tools like JLink that analyze what your application uses, and they can remove, I don't know. You don't use JMX? Out. I know that folks at Amazon did this exercise like a month ago. They cut like half of size of their GREs in their actual production, not on their client's production, in their own production, because almost no application uses all the modules that are there in JDK, and even in GRE, it's very, very excessive. So what is this 59 megabytes, if you think about it? It's like, this is an example with Spring Pet Clinic, like their model project they use everywhere. It's actually a very small application, right? It's an application with 4 pages, 2 forms, connection to database, that's all. It does nothing. So there is a way to further optimize it, if you think about it. So we again have this builder layer, which does absolutely the same thing, just builds our application. Then we have a new layer called optimizer. And it runs on GRE. We don't need JDK at this stage already. It copies from builder the pet cleaning application to our stage, changes workdir, and then calls this magic command, java-jar mode equals tools -jar, our application jar, extract --layers -launcher. Who knows this magic? Oh, cool. This magic was introduced somewhere around Spring 3.1. It is needed to split the application into layers. Let me show which layers are they. And we will see it in runner. There will be actually 4 layers. First of them is called dependencies. If you think about it, the major part of our application is usually dependencies. Sometimes it's not. Sometimes we write hardcore enterprise stuff, which is by itself weighs hundreds of megabytes. But for usual applications, we have like a couple of megabytes of code when it's compiled, and tens of megabytes of dependencies. Then the second layer is Spring Boot Loader. It's a magic of Spring Boot that allows you to detect all the dependencies and load from them. Then there is a layer with snapshot dependencies. Usually you won't have any snapshot dependencies in your production, right? Because snapshot dependencies are extremely unstable, but there are exceptions. Exception I faced in my practice was we found a critical bug for us in one of our libraries. We issued a bug on GitHub, and maintainer was so kind to say, okay, we are releasing snapshot right now. We cannot release the full version now because it requires excessive testing and so on. But since it's so important to you, please add snapshot repository to your build file and use snapshot dependencies. There is an issue though. they have rebuilt snapshot dependencies several times a day. Essentially, on every patch they edit, or every change they edit, they build new snapshot version. It means that snapshot dependencies change more frequently than usual dependencies. And then there is a layer with our application, which is probably the most frequently changing part, hopefully at least. If we do not change it often, if we do not change it frequently, it's either extremely stable or we abandoned it. Otherwise, I cannot imagine a situation where we don't have frequent releases to our main code base. Also, I changed my entry point slightly. Now it's not java-jar, it's Java org Spring Framework bootloader launch jar launcher, which is an arcane magic to call this Spring Boot magic to spin up the whole application when it's split into layers. Now, small diversion, I want to tell about this jar mode equal tools. It exists in every Spring application built with Spring 3.1 plus, if I remember correctly. It has two commands. First of them, extract, which actually splits your application into layers you can then reuse. That's how we use it here. But there is also a second command, which is called list layers. List layers outputs information in JSON format for you to be able to process it in your own way. For example, you depend on a dependency, internal dependency, which you know changes frequently. I don't know, let's call it my company comments. They change it every week. It's significantly more often than it happens to usual libraries like Apache Commons or something like that. In this situation, you probably want to put this library to another layer to not update all your dependencies, but to update more frequently only dependencies you know that they change frequently. So you can do your own way of processing these layers. You can create layers on your own. Spring doesn't really care, because for Spring, it's all almost in the same directory. But you can care. Now, if we look at the result of work of our builder, here it is. It's in the root, we have our application, obviously. Then we have, in classes, we have all this files, properties, and so on. Everything you have in your resources folder of your application, and database migrations. Then we have this magical AOP, generated annotations. We will talk about them a little bit later. Then you have your own code, like in my case, it's com GitHub Asmodee something. You have these two indices, class path index and layers index. Second one is kind of obvious. It's what Spring generates for you. Class path is also generated by Spring, but it's about which class path we will actually use in production. And meta information with all the information for native image you can potentially need. SBOM, who knows SBOMs? SBOM stands for Software Bill of Material. They become increasingly more important these days. When you ship your software, at some point in time, you may face the situation when you need to understand which tooling was used and which libraries were used to build this application. SBOM contains all of this information. Which compiler was used, which vendor was used, which version of compiler was used. You are not obligated to use Java-C to compile Java, for example. You can use Eclipse compiler. Nobody uses it these days, but it exists, and it will be in SBOM, and it's an important knowledge. If you need to pass the security audit, for example, well, they will see that this is vulnerable or non-vulnerable version of Java-C, so we can trust or we cannot trust this software. And if we cannot trust it, then we can probably rebuild it with non-vulnerable version. The stuff really happens, and I'll tell you more. If you need to make any federal contracts, for example, they have strict requirements on having this as BOEMs. Well, these days, I don't know. Politics is complicated, but this is how it used to be. Then you have a directory with your dependencies, where obviously you have all your jar files with dependencies. Snapshot dependencies, in my case, is empty. Spring bootloader, just a piece of Spring magic. And all in all, it's for Spring Pet Clinic, it's 212 directories and 500 something files, which is a lot of work we couldn't probably do ourselves, or would prefer not to do ourselves. I am so grateful to Spring developers that they automated it for us. And if you look at the structure of the resulting build, it's some GRE, so some data in GRE. Then we have layer with our dependencies. It's 57.69 megabytes. Then Spring Boot Launcher, 382 kilobytes. And then code of Spring Pet Clinic itself, compiled code of Spring Pet Clinic itself, almost 3 megabytes. And together it's 61 megabytes. And if you are really careful, you notice that 61 megabytes is more than 58 megabytes, and we were trying to slim our image down. So it's kind of obvious why it became larger. We unpacked a lot of stuff. JAR is essentially a zip archive, and we have unarchived everything. So it obviously became bigger. But the thing is, we're optimizing not in vacuum. We're optimizing for something. We're optimizing probably to improve performance of our pull and push. And in this case, in best case scenario, when no dependencies are changed and jar Spring Boot Launcher remain the same, the pull size and obviously push size will become 3 megabytes instead of 500 or 50 megabytes, which makes it for 1000 node, obviously 3 gigabytes of pull, which is still massive, but we should pull something. Like our application should weight something. It's extremely cheap on modern networks compared to half of terabyte we can potentially download and upload. And actually, at this point, we just reinvented how the BuildSofts, and not only BuildSofts, build packs work. Build packs, who knows build packs? Yeah, I didn't expect. So it's a Cloud Foundry project. It's a part of CNCF, Cloud Native Compute Foundation. It's a very nice way to build your applications if you don't want to think what's the correct way to build it. It's one command called pack. Then you have subcommand called build, which is obviously, I want to build this. Then Pet Clinic is just the name of our future Docker image. Then you select builder you want to use. If you do not select builder, the Pakilo build packs will ask you which builder do you want to use, and they have like a list of these available builders. For obvious reasons, I use BuildSoft builders here. Then you say which path, where is your application located. And then you pass one environment variable, which Java version you want to use. 21, again, latest LTS. This small command, which is relatively simple to remember, replaces the whole stuff we just did with Dockerfile. If you look at the result of its work, it's something like this. Here is GRE, then there is a layer of SBOM they create on their own. Then there is an application layer and BuildPacks application layer, which is our own application, and then launcher. They have slightly different vision. They say, let's put launcher on top. It's small, but if it updates, we don't it weighs nothing compared to our application. It's arguable, but it's still under 3 megabytes of pull and push every time. So build packs, actually transform your application source code into container image without you explicitly thinking what is the best way to write my Docker file. Actually, it's not only for you. If you have ops team, they can use it either if they have any, I don't know, trust. Usually they prefer to control things. But to me, it's almost perfect. Like, why would I write like 12 lines of Docker file when I can type one command? I can even alias it. I could create shell file in the root of my project or anything, run anything configuration in my idea to just run this Paquita build pack. And it will build Docker image for me, and then I can push it, whatever, do whatever I want. The idea of these Paquita build packs kind of reminds me of S2I. S2I is an idiom from Red Hat OpenShift. They have this idea like, push your code, we know how to build it, but it's vendor specific. Paquita build packs are not vendor specific. You can actually create your own build pack if you are willing to write code in Go. I do not, but you do you. It builds really better than default than many developers think about, like build it somewhere and put it into my image. It builds the same way as our optimizer does, and it is Spring-aware. So if it detects that there is Spring in your application, it knows that there is a way to split it into images, into layers, and so on. Is this all? Because we have actually optimized our pull and push size. Kinda, but not necessarily, because as I said, optimization is multidimensional. We can optimize pull and push size, but another thing we might want to optimize is startup time. If our application starts up for 5 minutes and our business isn't happy with it, we probably would prefer to fix startup time, not the size of image, because, well, we should choose. And there are several approaches to solving this problem. Three actual approaches and one future approach. I will probably mention a little bit later. They're class data sharing, coordinated restore at checkpoint, and native image. Alina Yurienko had to be here and tell you about native image. She isn't here, so sorry, Alina. I will probably butcher it. But class data sharing, it's a very interesting technology. It appeared in Java 5. Java 5 was actually the first Java version I used in production. So when I was significantly younger. The idea of CDS, class data sharing, was we run multiple JVMs on the same machine because, again, it was very long ago. No one used Dockers, and actually we didn't know anything about Docker. They didn't exist. So we actually had these hardware servers, and we had like one installation of JVM there, and we launched several Java applications. And CDS could help us because it saved information about JDK. It didn't need to recompile all the information on each start, and it could slightly improve startup time. How does it help us? Because we run our applications in Docker containers usually, and even if not, even if it's virtual machines or something, we do not run multiple virtual machines in single container. They can interfere in unpredictable way. They can have conflicts of dependencies, anything. It does not. It doesn't help us a lot at all. But in Java 10, they introduced a concept called application class data sharing, which is more interesting. It's like the same idea. If you run multiple JVMs with the same application, you can save not only JVM information in the spatial archive, you can also save compiled application classes in spatial archive, which again cuts you some time from your startup, which still wasn't useful until Java 13, where in JEP 350, they allowed us to automatically create these archives with class data on application exit, which means we can run application once, we can launch our load tests or whatever, then we can stop it, and it will automatically create an archive. We can reuse on all consequential starts of our same application. And this actually can help us. How does it work? Spring has support for it from version 3.0 maybe, or maybe 3.1. We need to use a couple of arguments. One of them is Java argument, -xx archive classes at exit equals, and then path to our archive. And one for Spring, -d Spring context exit on refresh. This one is interesting. We will talk about it a little bit later. We will mention it a little bit later too. The main idea is following. When we start up the application, it loads on non-lazy beans. Specifically non-lazy, because lazy beans can be very slow to initialize. They can have some side effects we do not care about, and so on. It loads all the non-lazy beans, and as soon as they are loaded, it shuts down automatically. We don't need to do anything. And since we have the first argument about archive classes at exit, it will save archive with classes of our application. There are a couple of limitations. First, we should use the same JDK to rerun application consequentially, which we used to run it the first time. The second, we have to use the same arguments with the same Java arguments, I should say here. Also, if we use this magical argument, -d Spring AOT enabled equals true, then instead of resolving all the dependency trees during runtime, actual runtime, Spring will compute the whole dependencies tree and save it to this archive too. So the next time we launch our application, it's already precompiled. Spring already knows all the dependencies, what depends on what. We can also do it during build time. It's just one setting in Maven or Gradle, whichever you use. It's something along the lines enable AOT compilation, which adds even more classes to our archive. Let's look at the Dockerfile again, because this magic is not done by build packs. So if we want this dimension of optimization, we should do it ourselves. So we have our own runner, which is based on JRE Slim. We change it let me show it again, from JRE Slim muscle to JRE CDS Slim muscle. The JDK should be compiled with CDS support enabled. Not all of them are like that. Like if you, for example, take default OpenJDK distribution or Timorin distribution, CDS probably won't be available there. I'm like 98% sure it won't be available there. So you need to use JDK with this functionality enabled. Then, after all these magical copies we already talked about, we had one more huge command. Run java-spring AOT enable true -xx archive classes at exit application JSA -d Spring context exit on refresh, and then org Spring framework bootloader launch jar launcher. We already talked about all of them. We want to enable AOT for all the dependency tree to be saved into our archive. We want to save our archive to a place called application JSA. We want to immediately shut down the application as soon as all of the non-lazy beans are loaded, and we use jar launcher for it. And also we change our entry point to something like this. As I said, arguments of JVM should be the same. So we passed again Spring AOT enabled true. If you won't do it, JDK will just fail and say, I see that there is a difference in arguments. it's probably something fishy is going on. Please fix it. Where do we load our archive from? It's obviously application JSA and the same jar launcher we used before. It is a big change to our Dockerfile, to our optimized Dockerfile. Let's look at what does it cost us. It costs us a lot. For pet clinic application, this application.jsa weighs 81 megabytes. So we really should know what we are doing and why we are doing it. If this archive would be like a couple of megabytes, it would be nice, but it is big. And with Project Layden coming in future versions of Java, this archive will become even better, even bigger and better, because Sebastian Deleuze, core developer of Spring Framework, told me that with Project Layden enabled, you can cut up to 80% of startup time from any application, which is amazing. Imagine your application is not starting not in 5 minutes, but in a minute, not in 60 seconds, but in 12 seconds. To me, it sounds actually very, very good. We're obviously trading pool speed for startup speed. And this is again about trade-off management. We as developers should choose our battles, like what's better for us. Even now, we can cut up to 50–60% of startup time from our application, which is also not that bad. Depending on the application, though, there are applications with which it will be significantly slower. For example, if you use WebJars, the old version of WebJars, they require the full class path scanning to load any CSS or JavaScript or whatever they called, and it takes a lot of time during startup time. And it's not it's done lazily, so it will be done on every application startup. So if we really want to push further, we can use a project called Crack. Contrary to CDS, Crack, it stands for Coordinated Restored Checkpoint. It's not a canonical part of JDK. CDS is a canonical, it's a part of specification and so on. You just need special build with CDS enabled. For Crack, it's different. There are only 2 vendors who provide you builds of JDK with Crack support. It's Azul and it's Bellsoft, at least open source. Azul implemented it first. Bellsoft, us, took the implementation, changed it slightly, and now we have it too. The idea of Crack is very, very simple. Imagine you launch your application, the whole application, lazy beans, non-lazy beans. You run your load testing suite on it. Everything is optimized, everything is beautiful, and it's all in memory. Now we just dump this memory on hard drive and stop the application. And the next time we need to start the application, we do not need to compile anything, like anything at all, because everything is already compiled and optimized. We just read the snapshot from hard drive, recover it to our memory, and work. It can save a lot of time. On my relatively weak machine, I can start up almost any Spring application I tried in like 20 milliseconds. Even big ones. Because again, everything is compiled. It's only a matter of reading from my SSD. And SSD says crazy hard. Oh, crazy fast. Not as fast as your memory, but still very fast. And in perfect world, Crack support in our Dockerfile should be very, very simple. It should be something like this. It should be jar e crack slim. This thing actually exists for both optimizer and runner. Then we should add one more argument called -xx crack checkpoint to /checkpoint. I'm putting it's a directory which will contain all the data about what we have in memory. And then in runner, we should copy our application to our image, our checkpoint to our image, and run Java with, it's actually very interesting. We run Java with one argument, where we restore our checkpoint from. We do not need to put any jars in there, nothing, because everything is just a memory snapshot. So Java reads the memory snapshot, restores it, and starts using it. He doesn't care if it was, I don't know, jar file or a bunch of classes or something like that. Sorry. But in real world, if we will try to build it this way, we will see something like this. Runtime exception, native checkpoint failed. And now I will show you an ugly way, or the ugly way, to work it around. First, we can add this directive to our Docker file, syntax equals docker/dockerfile1 labs, which means I want to enable experimental Docker features. I want to enable them because I want to have this option, run -- security insecure. If you will try to write it this way in your usual Docker file without this magical first line, it just won't work. Docker will say it's an incorrect syntax. So what we are doing here, we disable security when we create a checkpoint of our application. But it fails again, because when we are creating a checkpoint, operating system closes the application. And according to POSIX standard, if it's not like a graceful exit, the exit code will be not 0. If I remember correctly, it's 128 or something like that. It's not that important. But if Docker sees that one of commands exited with a non-zero exit code, it just stops building. So we add this magical double pipe true here to say Docker, everything's fine. And this is not all. To use this image, we will need to create custom builder, almost like buildpacks builder, with allow insecure entitlements, security insecure. Trust me, when the security team will see these lines, they will ask a lot of questions. And you better have answers to them because, well, something fishy is obviously going on. And we'll, for the sake of convenience, we'll call it insecure builder, just for everyone to know. Then we say that we want to use this builder to build our future images, and then we call Docker buildx build, allow security insecure, again a lot of questions, and then our typical build, Dockerfile with tag pet clinic crack, with output type Docker, and path to our application. Then to run this application, we still need to use -- privileged argument because it uses a lot of operating system magic. And when we do it, this is what I see. Sorry, I told you 20 milliseconds. It's 0.2 of a second. Still very fast, and my machine is not very fast. It actually works. And this is the whole run log we see in Spring. It's 4 lines instead of many lines they usually print, which can be considered a good solution. But is it a good solution depends on your definition of good. If it works is enough for you, then yes, it's obviously a good solution. But if you need more predictable and maintainable thing without experimental features, without security insecure, and so on, then no, it's not a good solution, but we can make it better. How would we make it better? I won't show you Dockerfile here, even though the whole talk was about writing beautiful Dockerfiles. The issue is we cannot solve this task with one Dockerfile. So I will show you a way you can do it. And I have another separate 1-hour talk about how to use crack and how to build images with this. You build jar file with your application. In Docker, outside of Docker, it's not that important. Then you create a new image that will run this jar with correct arguments inside entry point. So we just copy our jar file there and we say Java minus jar crack checkpoint 2. We'll run this container with 2 capabilities, and this is seriously better than -- privileged. 2 capabilities: cap CSP trace. We need this capability for Docker to allow Java to read from another process memory, which is a little bit dangerous. But if you know what you're doing, or if you were not the programmer who wrote this code, you're fine. And cap checkpoint restore. This one is kind of obvious. If you want to be able to checkpoint and restore applications, we need this capability. I honestly don't know why it exists. Probably for random applications to not checkpoint each other, to like isolate them. Well, here we know what we are doing. We know for sure that now we need this capability. Container will run and stop. It will actually stop abnormally. It will actually fail because on checkpoint, it will be again 128 exit code. But we do not care. We do this thing. We do Docker commit, then our container ID, and our new tag. This is all we should do. It will actually work. It has a lot of pros. It doesn't require any arcane magic. It doesn't require any experimental features. It doesn't require you significant trade-offs with your security. It works very predictable because we do not have this double pipe true. If something is going wrong during the build, we know it, we can control it, we can read logs, and so on. It doesn't require privileged containers, which is very important for your production, actually, because usually in your Kubernetes clusters in production, it's almost impossible to get a privileged container because privileged container can do anything to the whole Kubernetes cluster, which is a severe security issue. Consa, it will be organization specific. For example, you will have to understand how you should build this initial jar file. Is it like a separate CI step? Is it a separate Docker file where we do it? What are the best practices we use? And it obviously requires more steps. Everything before was about, we write this Docker file, we run Docker build, and it works. Not in this scenario. We need several steps. And now we have all flavors of ultimate Docker images. Did I hide from you the size? Okay. The size of crack archive for Spring Boot Clinic is around 500 megabytes. It's a lot. Like, really. We are almost back to the past where we had this ugliest possible image. Except this time, we know why do we need it and why we did it. It's a conscious trade-off. We really trade off traffic and hard drive space for speed of startup time. I didn't have the slide about native images, but native images are very simple from some point of view. You need 2 layers, one to build your jar file, and then build native image from it. It probably will be like one build tool command, like native compile and Gradle. And you need the second layer where you have nothing but this native image, like clean operating system without Java, without anything. You copy from builder, you copy native image from builder to runtime, to runner. It will be very slim, like tenths to hundreds of megabytes maximum. We cannot really make it smaller. What we pay for it, we pay a lot of time during the build time. A build of native image can take minutes, tens of minutes, depending on power of your building agents. Quick summary of what I just told. Use layers for faster deployment. This is what I would recommend for almost anyone until you have serious reasons not to do it. If you really care about startup time, but you're not prepared to pay a lot for it, use CDS. It's very simple. It doesn't require any code modifications. If you really need lightning fast startup, use Crack, coordinate restore at checkpoint. It obviously comes with a lot of compromises. Because all of the compromises you have when you save the whole memory to hard. For example, your credentials are there, and you need to find a way to somehow hide them. Use native image if you're prepared to sacrifice some build time, probably a lot of build time during in your pipeline. Luckily, you probably don't need to do it on your developer machine, but you will need to do it somewhere on the pipeline, and it requires a lot of resources. Thank you so much. I hope it wasn't too boring. You can follow me here. You can find a lot of material like this on this QR code. It's our blog. Thank you so much. Thank you. It's time for questions, I guess.
Questions, yeah. Questions?
Yeah, please.
So the one thing I feel like is missing, and maybe you could address it quickly, is when we talk about Dockerizing Java, RAL comes up.
RAL
VM precompiling the Java code to start up time.
Yeah, native image. Yes.
So how does that compare to these methods?
Startup time is amazing, especially if you are using commercial version of GraalVM. As I said, there is a huge trade-off you're paying during the build time. GraalVM build requires a lot of resources and a lot of time at the same time. It is quite an expensive process. It's very hard to imagine building like 50 native images at the same time in pipeline. And it is actually easy to imagine enough services and enough commits into your repository that you can have 50 parallel builds in your pipeline at the same time. At JetBrains, at my time at JetBrains, every time I looked at our build pipeline, we had like 2,000 parallel running jobs. They are either tests or builds. You will run all of them. Well, okay, JetBrains has complex project, right? IDEA is quite a complex thing. And no one tries to even tries to build IDEA with native image. It's impossible. No computer has such resources. So at least probably like supercomputers have such resources, but it's not feasible. Also, it won't support any plugins. In financial institutions I worked with, they usually had tens of parallel running builds just because they had a lot of teams. Imagine they all built native images. Do you really have such amount of resources? If the answer is yes, then probably native images is your way to go. Also, you need to know that the thing you run in production and the thing you test locally as a developer are completely different things. Like GraalVM native image doesn't pass and shouldn't pass JCK. It's not Java. It's a very good emulation of what should be happening. But sometimes behavior is different. Sometimes there are bugs in behavior. Like the issue tracker is not empty, as you know. I'm all for GraalVM native image, but you should know what you are paying for it. Thank you for the question. More questions?
One here. We have a question from the YouTube channel. So DQB decide this his handle, his or her handle.
Okay.
He's asking, what does require arcane magic though? Yeah. So
may I read the question real quick?
You can read. I don't know if. Yeah. Can you see that?
Oh, okay. So what does require the arcane magic though? If you want to build the correct image of your application with one Docker file, you will need arcane magic with all these experimental features and so on, and you will also need OK from your security that you can actually use it. I would probably prohibit it. extremely dangerous. It is potentially harmful for your environment if you accidentally do something wrong inside your application, because at the moment when you run, your application is privileged. You can call, I don't know, rm-rf/ and delete all the files on the machine. Anything, actually anything, because Docker, you can open Dockerfile, Docker socket, and send any command to Docker daemon that will do any random stuff. Extremely dangerous, not recommended. Thank you for the question, though.
Thank you. Yep.
More questions?
TCube Decide says thank you.
Thank you.
Okay.
Then that's all, I guess.
I think that's all.
Thank you so much, folks.
Okay,
Thank you for being here.
Yeah. Thank you.